Undefined function values. Let's say we are given the function f of x is equal to 4 over x minus 1 plus 2, and we are asked to solve for f of 1. So let's plug in 1 for our x value and try to solve. We will have 4 over 1 minus 1 plus 2. So if we simplify this, we will have 4 over 0 plus 2. But as you've probably been told many times in mathematics, you cannot divide by 0. And so when you divide by 0 in a function, we say that the function is undefined at that value. So at f of 1, this function is going to be undefined. It is not going to take on any value at that function. So even though we only divide this 4 by 0 and not this 2, this entire expression here is going to be undefined. If you divide by 0 anywhere, the entire expression is undefined. So let's look at what an undefined function would look like. Here we have the graph of our function, and if we look at x equals 1, you will see here that there's an asymptote, which means that the function will get infinitely close to 1, but it will never actually take on a value at 1. So not all undefined functions will have asymptotes. Sometimes there will just be a hole, and a hole is just going to be like a line, and then you have a hole there, and it would just be undefined at 1 point. But normally, if you're graphing something like this, it's going to have an asymptote, so it could be something like that, and then you would have your asymptote right here, and it would get infinitely close to this line, but it would never actually touch it. So let's try an example. Here we have f of x is equal to x plus 8 over x squared plus 5x minus 24. And we are asked to find the values where this function is undefined. How do we do that? Well, we already learned that a function is undefined when you divide by 0. So we're going to have a denominator of 0 somewhere. So we have our denominator here, x squared plus 5x minus 24. And we're going to have this equal to 0 for our function to be undefined. So let's set that equal to 0 and see if we can solve. X squared plus 5x minus 24 is equal to 0. So I'm going to write it as x squared plus 5x minus 24 cannot equal 0, because we need to know what x values we can't put in our function. So let's solve it like this. We'll get the same answer even if we put just an equal sign, but this just makes it easier to follow. So we need to factor this because this is a quadratic and we have it equal to 0, and we need to solve. So if we factor this, we've done this many times before, we just take our constant value here and we factor it and try to find two factors that add to this value here. So let's factor negative 24. Negative 24 can factor into 8 and 3, but we need one of these to be negative, and if we make the 3 negative, 8 minus 3 is going to be 5. So we can actually factor this into x plus 8 and x minus 3. And this cannot be equal to 0. So now we can split our factors and solve each one of them individually. So if we have x plus 8 cannot equal 0, and we have x minus 3 cannot equal 0. So let's start here. If we just add 3 to both sides, we will get x cannot equal 3. And then over here, if we do the same thing, we can subtract 8 on both sides, and we will get x cannot equal negative 8. So our function will be undefined at x equals negative 8 and x equals 3. Now you may have noticed that we had an x plus 8 in our numerator, and we also had an x plus 8 in our denominator, and we multiplied that by x, what was it, minus 3? So you could say, can't we just cancel these two x minus 8s and be left with, let me scroll over, and be left with 1 over x minus 3. Now, of course, you could do that, but it wouldn't get rid of your domain restriction of x cannot equal negative 8. So you would still have to add a little domain restriction here saying x cannot equal negative 8. Now, if you were just given 1 over x minus 3 without the original function we were given, then yes, this could be equal to negative 8. If you plugged in negative 8 for x here, you would get 1 over negative 8 minus 3, which is going to be equal to 1 over negative 11. And that would be defined at that value. But we were not given 1 over x minus 3. We were given x plus 8 over x squared plus 5x minus 24. And this function is not defined at negative 8. So no matter how much simplifying or algebraic manipulation we do, we still have to include this domain restriction. X cannot equal negative 8. So to conclude, a function will be undefined when you have a 0 in the denominator. So when your denominator is equal to 0, that's when your function will be undefined.